Hello? Hey, Medic, can you hear me?
Hello, everyone. Welcome to Print Busters. Couple of technical difficulties in the background there. Sorry about that. I am a professional, I swear.
Can you hear me now?
So I can't hear Nick. Nick, can you hear me?
Yes.
You can
Hello.
hear me. Interesting. Okay.
Can you guys hear me I can hear you both. Okay, so only Medic cannot hear me. Hello, hello. Can I edit my name? Let me see if I can edit my name.
So here's what we can do.
Furio Genki, how's everything? Oh yeah, I think I remember you. You have an awesome name.
Now I should be able to hear
Furio Genki, how's everything? Oh yeah, I think I remember you. You have an awesome name.
Now I should be able to hear
Furio Genki, how's everything? Oh yeah, I think I remember you. You have an awesome name. Furio Genki, how's everything? Oh yeah, I think I remember you. You have an awesome name. Furio Genki, how's everything? Oh yeah, I think I remember you. You have an awesome name. Furio Genki, how's everything? Oh yeah, I think I remember you. You have an awesome name. Furio Genki, how's everything? Oh yeah, I think I remember you. You have an awesome name. Furio Genki, how's I think I remember you. You have an awesome name. Sorry, I muted you, Medic, because he's repeating. I don't know what's happening. So Curio Junkie, that was the best repeat ever, right? I don't know what's happening on. Let me unmute you. Is that better now? Can you hear me?
I guess I have no audio at all, but that's okay. I don't need to hear you guys because I have the chat. As long as you can hear me, we'll be all right.
Let me try.
In here. D, welcome in. Polymorph, the other medic. Welcome everybody.
Let me try this because if we cannot talk, that's
so. What are we doing tonight, and why? So one of the first things that got me started in Print Busters, what was it, Nick? 2 years ago now.
Yeah.
It may not have been the first thing, but the first thing that I remember well was Hatchbox had just released a new PLA. They called it the PLA Pro Plus. That
I'm asking you to check his Discord chat. I really hope we can talk because otherwise it's not gonna be easy.
They said. Now Nick can hear me. I can't hear Nick. That's the problem. Which is unfortunate because nobody wants to listen to me.
You can try. Can you check your private chat or check private chat? Check private chat. Check your Discord. Yeah. We need to make it work.
So Hatchbox had just released their PLA Pro Plus, which they said was had a really high HDT.
Okay, there you go. Device not connected. Okay, he's trying in the background. That's great. That's professional. He's talking and trying in the background.
Nope. Still
not working. This is
Nick, hang on. I'm gonna leave the studio and try coming back. I'll be right back.
Okay. Okay, but you can hear me well, right? I will try to invite him as a guest on it. So maybe because we are both on the account, maybe there's something wrong on his side. Um, not too sure what. Polymorph, how's everything? The volume you both had was great. Yeah, it was. It looked nice, but it won't work if we cannot if we cannot communicate, right? That's gonna be so strange. So let's try a different way. And yeah, so basically, I don't know if any of you join on Tuesday. We talked about the carbon nanotube and carbon nanofiber health risk, and the idea on Friday. Oh no, it's still not working. Device not connected. And basically on Friday, what we're gonna do is Medic is gonna break some stuff at home, and then hello, can you hear me?
I can hear you now.
Whoa, victory!
All right.
I think it's better if we can talk. Otherwise, it's gonna be so strange that you're like no sound on your side. Okay, so you were saying you started actually. I forgot about it, but yeah, I think your first test was it the Hashbox PLA Pro Plus?
I think that was the first one. I can't remember for sure, but that was the first one I remember. So they were making some wild claims about an HDT of, what was it, 70 degrees?
I think
75,
so.
something like that.
Yeah, correct.
And I said, there's no way that's for real. Absolutely not. So I got out my my toaster oven and I made little test strips of PLA, PETG, and the Hatchbox stuff. And sure enough, that claim was legitimate. And not only was that legitimate, but it's probably the best PLA I've ever used. And I never would have touched the stuff if it wasn't for Print Busters.
Yeah.
Now
yeah,
it's
remember, yeah.
It's like $36 a kilogram, so I'm never going to use it again. But it's very good stuff, and it fills a really good niche that previously wasn't filled.
Yeah, that's true. I remember I think we were talking about the PLA HT and all the different ways to get the HT by annealing, etc. I think we were browsing on the net, and then we found this one, and then we were like, "Oh, that's a pretty big claim." And then we started testing it, and then I remember when you posted the result, it was like, "Oh, it's true! How crazy!"
Yeah. So I tested that, and I said, well, that's great, but what did they sacrifice to give us that? So that got me started on the tensile testing.
Okay.
And we started with these. I can't see that against my black shirt. Started with these test hooks. Now, this is not a tensile test, but I think it gives a really great real-world example of how a print will function under stress.
Mm-hmm.
So it's pulling it this way. It's actually going to bend a little bit. So we're not getting a tensile test, which would be 100% straight line. But this combines a couple of factors that I think give me a better understanding of how the material functions in real life. So that's why I'm using these hooks.
It's like an overall test, right? There's like a bit of bending, a bit of tensile. Well, maybe not that much of impact, but it's like an overall idea of how strong the material is, right?
Exactly. It gives. So I haven't been calling it tensile strength. I've been calling it strength, which I'd love to find a better name for it, but that's the best description that I can give people right now.
A hook test.
Yeah, it's a hook test. So that's great. But now the problem is we have nothing to compare that to, right? So we had nothing to compare that to until we started doing more tests. So
you mean the hook test? Like
yes.
Like we needed. Yeah, we need to compare with other hook tests, right? Is that your meaning?
Exactly. So we need to compare with other hook tests. So I started putting together a list just for myself of how these things were comparing to each other, just hook to hook. And I did a couple, and I said, well, maybe I should just start testing every material that comes through here, right? I have more than one spool behind me. I might as well run them all through the same printer at the same settings and see how they come out.
Mm-hmm. Mm-hmm. And
then
is all the one you tested already? Like,
these are the ones that I've tested so far.
oh, and so what do you record exactly? So the brand, the material, and even the color, right?
Yes.
Color.
So
Do you go down to the batch number or?
I don't go down to the batch number. I'm not.
Okay.
I'm not crazy. I can't keep track of all that. But so I had 4 or 5 different materials on here, and I was just testing, one of Polymaker PLA Pro, one of Polylite PLA, one of Polymax, to compare that with Bamboo PLA. And then someone told me after I built a white printer that they had some harsher words for me, but I was crazy for building a white printer because white materials are so much weaker than any other color because of the additives they use to get the white coloring. On paper, that makes sense, right? So if we read into it, the titanium dioxide that most manufacturers use to make things white should technically make it weaker.
Should technically make it weaker. I would say on paper, my theory would be it would make it more brittle, like from an impact test perspective, but it might actually increase its rigidity, I would say, because you're adding like compared to like rock, basically you're adding like rocks in the material. So, but that's the theory, right? I'm not sure practical whether it's gonna do that. Would you say it will make it weaker in all different type of strength?
Personally, I'd say no, it won't make it weaker in every possible way.
Okay.
But I don't like saying things like that without having numbers to back that up. So I asked this group of people for any kind of information they had to back that up, and they gave me nothing. So me being me, I went to the Polymaker website, and so everybody knows I am not affiliated with Polymaker. I may be wearing the shirt, but that's just because I got this at Rocky Mountain last year. Oh, that was this year. Sorry. Rocky Mountain this year. So I went and I spent my own dollars, and I bought every material that they currently had on their website in both black and white. And I have started putting together this list. You can see I've done some. So here are all of my black materials, and here are all of my white materials. And apparently I can't spell white. So I started, and tonight what we have are Polylite PET G in both black and white, Poly Smooth that I have smoothed in the Polisher, which I can say I did not pay for. That was sent to me specifically to do this testing. It's really nice. If you guys have never used Poly Smooth, it's really cool stuff. I already tested Silk White. I now have Silk Black printed to test as well. And then we've got some extra stuff here. I have PET CF, KVP ABS in Stellar Red, nylon from Fadis, which they call Ease PA, and a material from IC3D called Polyhex that they are advertising as a high temperature PET G.
High temperature PET G.
That's paper, what they say. On paper. That's what they're calling it.
Okay, well, what's the number of on paper? Like, is that a bigger, larger SDT or no, even a larger TG, I guess, if it's a PTG.
So I haven't really looked at the numbers yet. I just got the TDS from them yesterday, and unfortunately, work lately has been a little bit out of hand.
Hi, Zombie.
So,
hi, Silverback, Nick. polymorph, medic, the other medic, or the first medic, I would say, or
That's the other medic. So they're calling it high temp pet G.
Polyhex. Oh, that's how they write. Okay.
Yeah,
Nice.
polyhex. So the first time I saw it, I thought it was a polymaker material. It is definitely not.
Okay, so what did they say? Print surface. Print
So
surface
they're saying
100 and oh, okay, that's interesting.
yep, so that's the bed temperature on the right. On the left, they have the glass transition temperature at 110 and the HDT at 99.
Oh, you know what? Do you think that could be is similar to the Polymaker PC, right? Like it could be some similar, maybe similar formula, and because that's the glass solution temperature. That's interesting. Ovality, 4% density.
So that's what I'm thinking. I think it has some kind of PC in it. Because when I've had this for over a year now, and I haven't opened the spool until the other day.
Okay.
When I got it from them, it was still kind of beta phase-ish.
Mm-hmm.
They weren't selling a lot of it, but the way they were marketing it back then, instead of high temp pet G, they were telling us more along the lines of an easy to print PC.
Oh yeah, that's how they describe it. Warning: polyhex use will make your polycarbonate obsolete.
Oh, it says it right there, doesn't it?
Yeah, copolyester that combine the best qualities of PC and print ease of PTG. Oh, okay. What did they say about the BPA? Let me try to zoom in a little bit. Offset printing with polyhex have the same strength, durability, chemical resistance of legacy polycarbonate without the typical PC, I guess, downside, warping, smell, BPA exposure. Also, it's BPA free. That's interesting. High printing chamber. Okay, so how did you print that? Did you print it in a chamber or?
I did. So I printed this on my 2.4, which I currently have set as not high temperature, but I'd call it medium temperature. I get the chamber up to low to mid 60s. And this was not pleasant to print.
From a smell perspective or warping perspective?
Just overall printability. It was definitely not an easy material to work with.
Okay.
I started at their recommended settings, and it was stringing like crazy. The layer adhesion was poor. They had to do a lot of work to make it print well, and it's acceptable, but it's not something that I would say is. I wouldn't try and sell these parts.
Okay. By the way, you can share your screen differently than your camera, so that sometime we can just put you in bigs if you want to show some stuff.
Nobody wants to look at me, Nick. They want to look at the cool stuff.
Yeah, but the cool stuff is in your hand. Yeah, if it's easy to do, yeah. Then,
all right, so this is the polyhex. See if I can make this focus. So the layer quality is not the greatest. There's some lines there.
Was it dry? It feels a little bit
yes.
Like.
So this spent 24 hours in a poly dryer, so I'm hoping it was dry.
Okay. Level 3, I imagine, because it's like pretty high TD.
That's all I do. I don't bother with the first two.
Okay.
If PLA melts in there, it melts. These are just 3 all the time.
Okay. Yeah, that's interesting. And you
Zombie? No, I did not level the bed. It's pretty rigidly mounted in there. It's a 2.4, so I didn't adjust it at all.
Do you remember Raft? That's how we solved the. Do you remember when have you ever printed with a Raft?
Yeah, about 8 years ago on an Ender 3 before I knew better.
Yeah, that's how we solved the bed leveling before, right? You print that massive
yes.
layer.
They used to use so much material, it's ridiculous.
Yeah.
Oh my goodness. So that was a whole 20-minute long explanation of how we got where we are. So I also printed, these are what I use as, I'm using black against my black shirt again. So this is what I've been using for not technically HDT test, but temperature testing. It's just a bridge. I printed on its side with enough walls that it is just 100% walls. So I'm doing 6 walls and 100% infill. There's no infill. It's solid.
Did you have some I think you had some preliminary result on black and white, right? I remember you shared that on Printbusters as well.
Yes. So I have some black and white results so far. Now, I've only done the strength testing for reasons that I'll get into. But so far, if we compare material, so ASA black and white.
The results are a gray area from Zombie.
Yeah. So the results are a gray area, not only because it's black and white makes gray, but because they are so close that I can't call it based on these numbers alone, which is why I didn't stop at PLA. So ASA, we have an average of 30.46 for black and 30.35 for white.
Oh, which is basically okay within standard deviation, basically.
Right. That's within the measurement capabilities of my very high-tech strength testing machine right here. So Polymaker PLA Pro in black 39.86 and white is 39.
Okay. Yeah. Zombie say, it's good to know. Is there an easy way to test abrasiveness? Yeah, so that's the second thing that people are asking about the white, right? So number one, it's weaker, and that's what Medic is testing. And number two, it's more abrasive. And I also think I do have some plan to test abrasiveness with microscope, but I think Medic also have some idea on testing abrasiveness, right?
I do. So I thought I had it out sitting next to me. I don't. So I built it's a hot end and an extruder, or hot end and an extruder, just mounted to the desk. I'm going to put my garbage can underneath it, and I have a stack of brass nozzles. I'm going to run a full kilogram of black through one nozzle and a full kilogram of white through another nozzle, and then we can compare with my $20 microscope here. And we can check out the results once we get that done. But I do want to use brand new spools for that, just so I know I'm running exactly the same amount through each. And I have not ordered another spool yet. So that is on my to-do list. I just haven't completed it yet.
I do have a small. Let me just answer the question first. Nick is saying, is that testing layer adhesion or material strength? Are you testing only XY, or are you doing some hook in the Z-axis?
Right now, I only have XY, but Z-axis are on the list as well. It's just a lot of printing that I have not been in this room to get done.
Yeah. Okay. Well, yeah. So I do have a small challenge for your abrasive test. What I learned is that from some of the testing we have done is that the abrasion also come. I don't have enough tests to say for sure, but
the pressure while it's actually printing against the bed, right?
So it mainly comes from the fact that it's rubbing against the other layers, and that's kind of like a sandpaper that you are rubbing your nozzle on it. So I heard that, and we have a few testing showing this. Like, I remember we testing it without printing and with printing. And with printing was like cutting the nozzle. I mean, it was carbon fiber and it was brass nozzle. And without printing, it was still bad, but compared to the other, it was night and day. So we might want to have like two different testing, one that is the one you design and one that is maybe more about actual printing, because the result might be different.
Yep. So that is step 2. I want to see how it works through the nozzle just on its own, printing in the air. And then I have like 30 nozzles here that we're going to end up going through. So step 1 is just printing into the air. Just set my maximum extrude distance to infinity and beyond. So after that, I have a printer here that was previously decommissioned. You can probably see them under my desk back there. Those need to get put back together so that I have a printer that I can just run full kilograms through and not worry about taking time off of these machines and swapping nozzles and all of that. So once that gets back up and running, we can run a test on an actual machine.
Nice. Hi, NSTO. Thank you for joining.
A 1 kilogram cube. If the bed is big enough, I will see if we can do that.
Transforming 1 kg of filament into a cube.
That's a big cube.
For testing. Would that be big? Let me check. I mean, it should not be that big because it will be smaller than the spool, right? I mean, it will be smaller of what the filament is taking as a filament, right? So, like, let's say the filament altogether is like around this, like my head. So it won't be that big of a cube, right? Should fit.
Okay, yeah.
100%.
At 100% infill, we should be able to do that, yeah.
Excel. Yeah, I think you have some printer on the way or in your mind.
So I have the XL here, but that can't take the V6 nozzles right now. So that's out. Although I do have 2 brass nozzles for that. We could, but they're used, so I don't. That's just not a good test. So this is my test jig. So you guys, I've talked about the CNC kitchen open pull, and I think most of you guys have seen the one designed by Edge of 3D. Really nice, motorized, great machines. This one I put together real quick from stuff I had around the house. It is just a 4x4 that I had left over from a project, 2 eye hooks, and this crane scale was $22 and change on Amazon. And it does get similar results to what Edge of 3D was getting off of his machine. And it's very consistent. The hooks break almost exactly the same way every time. And over a course of 4 hooks, which is what I've been doing, I do 4 of the same material, I get really close numbers. So I'm happy with the consistency. I'm happy with the accuracy. It's not perfect by any means, but my goal was to fit anybody's budget. And I think we got pretty close. You see the blue printed part on there. That's just keeping the meter straight so that when it's on camera, we can still read it.
Because all in all, that's what, like $30 worth of material? Everything?
Yeah, right about that.
Yeah.
And it doesn't have to be a 4x4 either. Anything that's stiff and you can mount the meter to will work.
Okay, so there's a lot of breaking for today, right?
You guys ready to start breaking stuff?
Always ready to break some stuff.
Good, because that's the only thing in life that I'm actually good at.
Let's break some stuff and learn and see if white is really weaker. Maybe for some of the other materials. Let's see.
All right. So what do you want to start with?
So you said you had Oh, the polyX. I want the polyX. Let's go
You want
straight.
the polyhex?
Yeah, let's go
All right.
straight into that one.
All right. I hope everybody can read this, or is my light in the way?
Not yet. Actually, when you pass in front. Oh yeah, when you are in front, I can see. Like when you. Yeah, now we can.
Right here. That's good.
No, like when you had the light. Okay, now we can see. We can see 0.00. Okay.
All right. So I have 4 samples. This is my very high-tech pulling device. It is a ratchet strap that I pulled out of my truck. So I put the hook here, and there's another eye hook on the bottom. I just right between the two, and then ratchet nice and slow.
Oh, when it's light up, then we cannot see the number. Can you put your hat just next to the screen? For some reason, we can see it. Like if you put your head next, you see every time you pass in front, we can see the number. But now we cannot see. It's too bright, the screen. Not sure if that's something that can be changed actually. Yeah, you see, every time your hat you go in front, then we can see. Yeah, you see what's going on?
You can read it now?
No, it's like when you go in front like this, then it's somehow it's. Yeah, I don't know why. How is it doing this? Is it the autofocus? Yeah, maybe. Oh, exposure. Is it exposure? Did you notice, guys, when his hat is going in front of? No, now it's not working. It's not working. It's really when you pass in front of the screen, then somehow it makes it much clearer.
That is one of the weirdest things I've ever seen, Nick.
Yeah, I don't know. Zombie is
All
talking.
right, so I just have to stand kind of like this.
No, still no. Whoa. Okay, what was the number?
So that is 23.55.
Okay, 23.55. Okay, you know what? What I can do? Let me do something like this. Give me a second. Do this, 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 and then this. Oh, okay, maybe. Like this, and then something like this. Okay, so what was the first one? It was polyX black, right?
Yes, sir.
And it was 23 what? 55?
55.
Okay, kg, right? That's the unit.
Yes, we're in kilograms right now.
Okay, so what temp did you print that at? What was the temperature for polyX?
290.
290. Okay, black number 2.
2365.
2365. Okay, I should do this on Excel. I don't know why I did it here. Share the Excel instead. Next, we should do one white. Oh, what was that?
2180.
2180. We should do one black, one white. One black, one white.
Well, I've only got 2 printed in white here.
Okay.
But we can go back and forth.
And I guess the white, was it using exactly the same G code?
So no, these are different materials. So it's the same model with the same number of walls, same amount of infill. But
yeah,
we have, this is polyhex. In white, we have PET G and polysmooth. Now, I did use the same G code with different colors of the same material.
Yeah. So like poly-X white, do you have poly-X white, and it was the same as poly-X black, or?
Polyhex is only available in black.
Oh, okay, got it. What was the number now?
2135.
And that was the 2135. That was the sample 4, right?
Yes, it is. So
Okay.
that is kind of disappointing.
21. How does it compare with your others? Like, what was did you do the Polymaker Polymax PC, for example? It has similar
Yeah,
over-
so Polymax PC in black averaged 54.025.
54.025. Okay. And this one average. Oh yeah, that's interesting. Okay, got it.
So I think there was something up there. I don't think this is accurate. I am going to dry it again
Yeah, maybe
and retest it.
because the surface quality feels a little bit like it's a little bit fuzzy, bubbly, something in this.
No, it doesn't feel fuzzy or bubbly,
Mm.
but it feels like if I didn't print flawless prints before and after this one, I would say it was inconsistent extrusion rates.
Mm. Yeah,
It's
maybe.
possible that it's slightly under extruded, which would cause bad numbers there.
Mm.
But the top surface is good.
Interesting. And so, what was the temperature you print the Polymax PC at? Was it hotter? You remember?
No, it was not hotter. I think I printed the Polymax at 280 or 285.
Oh, okay. So, okay, got it. Yeah, well, at least it does seems a little bit strange. Do you have some PTG data? Maybe we can compare with the PTG one, because it's supposed to be a super PTG, so maybe it's better than the PTG.
So I have electric blue PETG with an
Uh,
average of 42.135.
42.135. And blue PTG, is that the Overture PTG?
Electric blue is Polymaker.
Oh, Polymaker PTG. Electric.
Now we can compare it to the IC3D PETG with an average of 38.1.
Okay, so yeah, that does feel strange then for the poly-X. Or maybe was it because of the chamber? Maybe it requires a much higher chamber temperature.
It could, and that's one of the other things I'm testing. You guys can't see the sheet right now, but I have the same material tested at multiple different hot end and chamber temperatures.
Hmm.
So, unfortunately, with the setup I have now, I don't have an actively heated chamber. So
Okay.
I can't say I want the chamber at exactly 50 for this test and exactly 60 for the next one.
Mm-hmm.
On my list of things to purchase eventually is a printer with an actively heated chamber like the X Plus 3, I believe was the one I was looking at the strongest. So you can actually tell it, I want the chamber to be a certain temperature, and it'll keep it there. I have a heater to go in this, but I don't know how well that's going to work.
Mm-hmm.
I'm a little bit disappointed in this one.
What's the number?
So this is Poly Smooth, smoothed in white, and I smoothed it about a week and a half ago. So if you guys aren't aware, Poly Smooth doesn't harden up completely for about a week. So once you get it smoothed, It's going to be very sticky at first. Let it sit on the plate for 24 hours-ish before you touch it at all. Otherwise, it's going to have fingerprints. Once it hardens up enough to touch, let it sit somewhere with good airflow for about a week. It's about how long it takes to actually finish hardening all the way through.
Yeah,
Zombie says X1E. X1E is a lot out of my budget.
And it doesn't offer a heated chamber, right?
It does. It does.
Oh, it does. Okay, controlled.
Yes, the
chamber.
Yep.
Or?
Controlled.
Oh.
The chamber in the X1E will go to 60 degrees versus the 65 on the Cheetah.
Oh, really? Does it has heaters, or is it using the bed, and then it's just?
It has a chamber heater, yeah.
Oh, I didn't even know that. Okay.
So 22.75 for the first white poly smooth.
Okay, that's recorded. By the way, guys, all the data will be available at printbuster3d.com. It's just the website is still under development, but all the data you are seeing here will be free and public on that website.
So what we have so far is actually already available. Right now it's hosted on Google.
Oh, so, yeah. Let me check the link so that everyone can. We pinned that in general, right?
I believe so.
Okay, here you go. This is the Google Doc where everything is shared already, and it's also pinned in our Discord. And here's the invitation to Discord if you guys want to join us there.
So not only is this information available, but there is a form you guys can fill out when you do your own testing to submit your results. That is my favorite part, because the sample size that I have here is 4. In a scientific test, this is not a very good variety. The more times we can test the same material, the better our results are going to be. So if you guys have done any testing or you plan to do any testing, please, at the top of that sheet is a link to the form. Submit your data, and that'll give us a better idea of how it's working for everybody.
Hi, Chewy. Welcome in. We're breaking polysmooth white smooth at the moment.
That's more like what I expected. That is 36.1.
Oh, interesting. You know what? It might be the smoothing process that is that makes it inconsistent in a way that it might really depend on how well it has been smoothed or something like this. And then,
so the black was fairly consistent.
Oh,
I had
okay.
The black, I had a minimum of 32.34.
Oh, interesting.
Nope, I'm sorry. That was the average. A minimum of 33.1 and a maximum of 35.2.
Okay, sorry, what was the average again?
The average for black
Actually, I could open the link. Let me see.
32.34.
32.34. Okay. Maybe inconsistent wall width from the smoothing. Maybe let's see how is the other very smooth white perform, and then we'll see. We really have the Printbuster crowd in the chat. I can't remember all of these names from previous Printbusters. Are we above 30?
We are almost at 40. We're 39.4.
Ooh, okay. Looking good so far. Looking good. So right now the average is similar to black, maybe a little bit bigger, even with that bad sample. Okay. Whoa. Let's break that one.
35.75.
35.75. Okay, that's pretty good. Okay, so yeah, something happened with the first one. I don't know. They may. Yeah, something. That's why we need more data.
That's exactly it. Having more samples tested will give us the ability to remove the outliers.
Yeah.
So when something is obviously not right, it's not that we don't count it, but we count it differently.
Yeah.
It's documented, but not really part of the average.
The OG Printbusters. Yeah, exactly, Anasio. That's really the name that I see in the chat is remind me a lot of memories. Okay, so now we are switching to what is this? PTG Black.
Oh, you can read it. I was going to make you guess.
I can read PTG and I can see it's black, but I don't know which brand
Yes,
it is.
this is black polylite PETG.
Okay, Twilight PTG Black. Okay, let's see how this one performs. Oh, interesting.
41.
41 and
4110.
4110, and a pretty ductile behavior.
It is. Very much so.
It would be helpful to look at the break under a scope too. Don't you have one, Matt? He has. He
do.
He has a microscope for the abrasiveness test. So, Chewy, let's go PTG. Right now is the biggest number on the table at the moment. I mean the table I have here, but you can also open the Google Docs to see all the other documents, all the other data. What I'm gonna do next time is I will share directly the Google document so that you can see all the numbers.
Test 2 is 3960.
3960, not too bad. So it's very, very similar to the electric blue. Actually, electric blue
be.
Yeah, it's a bit bigger at the moment, and then similar to IC3D PTG as well. So all the PTG are similar to each other so far.
$40.05.
40.05. Okay, yeah, nice. Welcome to the Friday workout for Medic.
Yeah. I'm going to be sore tomorrow. This is more exercise than I've had in a long time.
Next time we're going to meet Medic in a RipRap festival, he's going to have big arms.
I'm going to be walking around like this.
So, Team PTG is back. Have you tried Bamboo HF PTG?
I have not.
Not yet. Yeah, exactly. Curio junkie. And excuse and throw your back out. Okay, sample 4.
3990.
Okay, so yeah, it is still. So if I do, well, actually, we can do 40. So it's 5%. 5% weaker than the electric blue. So it's not negligible, I would say, from 42 to 40 from 4 sample. Yeah.
So here's the comparison that I am looking for is the black and the white. So if white is supposed to be the weakest, what is the exact opposite of that but black, right? So for me, that was the comparison.
Yeah, well, depending on how you define opposite, right? If you define from a color perspective, okay. If you define from like how it should affect the mechanical property, then I would say undye should be the opposite, right? Meaning,
So natural, I guess, would be the
yeah,
best thing to compare it to as a baseline, right?
I think so. I think so. So that scientifically we have one without the dye, one with the dye, so that we can know how the dye affects it, right?
Does Polymaker sell natural PETG?
Yeah. The transparent one is dye-less. And
And how
then
about PLA?
yeah, PLA, there is a natural, ASA, there's a natural, ABS.
All right. So what you're telling me is I have to go place another order.
Yeah. So we need to put
So
together.
this is a sales pitch. You're trying to sell me.
I'm not from Polymaker in that stream. So we do need to put some funding for Polymaker. So we most likely can have a pretty good donation from some companies, especially one that I know. But outside of this, we'll try to do some great content and gathering some. Another ductile behavior. Nice. I like that.
So that's what PETG is known for. So this is what I was expecting. I wasn't expecting something spectacular like with the PLAs. I was expecting something more along those lines. Which this is very similar to how the Polymax PLA will break.
Yeah.
It's a lot more ductile than the rest of the PLAs.
Yeah. Absolutely. Wouldn't
And
be without additives or natural? Yeah, Curio Janky, exactly. There is a big delay between the chat and what we're talking about, so apologize for that.
Discussing consistency.
Oh yeah, exactly. Oh, that's impressive actually. Exactly at the same page. Is that maybe it's the way the hook is designed? Maybe it's the weakest part of the hook.
I think that is the way it was designed, but you can see I don't have any PLA broken yet. We'll get there. We'll break something else and compare it.
That was the Polylite PTG white, right? Or is that another PTG?
Yes, that is Polylite PTG in white.
Okay.
And that first test was 3965.
Okay. Yeah. Chewy, natural should be the true strongest. Yeah, that's actually something I would be interested also. Is the dye making it weaker or stronger, or no change at all, right? So I'm also interested in this because a lot of people are using natural because they think it's the strongest, but I'm wondering whether it is indeed stronger or not, and stronger from what perspective, right? Tensile or impact. Okay, sample 2.
3920.
Yeah, so far we're pretty close to the black. So it doesn't seem to be that much weaker at the moment, comparing the black and the white. You may need to refresh their stream. Oh yeah, so if you feel like you are quite behind on the stream, you might need to refresh, and then you should be a bit more in sync with us.
Number 3 is 3825.
Oh, okay. So that makes it a bit weaker. Start to be a bit weaker. Is the colorant just pure colors, or is there like a binder plastic in it as well? Well, depending on which step you are, Chewy. The first step is a pure colorant that you are mixing in your master batch, and then the master batch is then putting in your extrusion of the filament, right? But it always starts with the pure color powder, right? And then it's mixed. Sample 4, 40, 41.6. Okay, nice.
4160. So that gives us an average of 39,675.
Yeah, which is very similar to the 40.16.
So to me, that's not a big enough difference to say white is so much weaker than black, don't use it.
Yeah,
But that's just my opinion.
I agree. So so that would be, so it's 1.2%. White is 1.2% weaker than black according to this test. So it, yeah, not conclusive, I would say. Not conclusive. It would be amazing at
So,
some point when we have like all the materials, all the colors, 50 tests for each of them. Then we're gonna have
so
a really amazing data set.
that's my goal, is to have all of us testing any color that we can get our hands on, so that we have the data points to really say definitively, here's the data.
Mm.
So that was my last white sample tonight. So I just want to go real quick by color. So we have, I don't have, oh, that's Vegas.
Oh, by the way, we are going to link all of this in a Power BI so that it's you guys can draw your graph and take some screenshot and share it around. It will be quite visual.
So here is black and white ASA from Polymaker. The black had an average of 30.46, and the white had an average of 30.345.
Sorry, where are you looking right now?
So black ASA,
Oh, okay.
30.46.
Black ASA, yeah.
And white ASA, 30.345.
This is behind your name on
Behind my,
yeah, on the screen you have your name, because you're not sharing your screen, you're sharing, it's your camera where you are sharing the screen on the camera. You can share your Excel if you want directly. Then we can see the whole screen. But yeah, it's just behind your name. Oh yeah, there you go. And then your own camera can be switched to. Yeah, there we go.
right, to the part nobody wants to really see. All right, so black ASA 30.46, and in white we have 30.336.
Okay, maybe
So it is,
zoom in a little bit on the Excel for people to.
is that better?
Yeah, perfect. 30.35 and 30.40. Oh, really? Okay, so basically the same, right?
Right. So basically the same, which is more or less what we saw with the PET-G, right?
Yeah, okay. So we have ASA black, ASA white, relatively the same.
I've
PGG
got
black,
some,
PGG white, relatively the same. And now you have PLA Pro black. And you have cold white, line 28. And now we have 40.1 and 39.3. So similar to PTG.
again, very close.
Yeah, very close. And I'm also wondering, maybe at some point we will find the weakest. Could be pink, could be red, could be yellow. Yeah, and maybe you know what, we can work with the filament manufacturers to understand the percentage of the color master batch, and maybe at the end of the day it will be more related to how many percent of the master batch is being is used per filament instead of the actual color. Maybe because some of the master batch are like 5%, some are like 2%. So that could be more related to this rather than the dye itself.
Polysonic, another PLA, I have 35.99 in black.
Yeah.
And 35.46 in white.
Okay. Also very similar.
Very, very similar. And then we have Polytera. Oh, you only have black, right?
I only have black?
Looks like I cannot find the white.
Okay, we haven't done the white yet.
Okay,
So
25.74.
all the numbers we have so far are so close that I can't say one of them is stronger than the other. But again, I'm one person, and I've only tested 4 samples of each. To really have high quality data, we need more data points.
Yeah, I agree. And maybe so this is pretty good for a representation of the overall strengths when it comes to like bending, rigidity, tensile, kind of a combined test. Now we need a way to understand more on the sharp strength, right? Or sharp stress, like impact. Yeah, I only have impact that comes to my mind, but maybe from an impact perspective, there could be differences between different colors. But yeah.
So in the context that it was given to me was that it was white is bad for building a printer.
Oh yeah.
So to me, that says it's not impact strength, because I really hope that nothing is impacting my printer while it's printing.
yeah, that's true.
If it is taking an impact, we've got bigger problems.
That's a good point.
That leaves a strength test like this and HDT.
Yeah, and temperature.
So
maybe the white impacts the temperature performance. Oh, I heard something else. I heard that that the white was more or less banned from the PIF. So not only weakness, but also print quality. I heard that white was printing worse than other colors. So that's maybe something that could also be tested. Let me put you here. Oh, there you
go. All right, behave.
Smart camera.
What do you think, Nick?
From what I see, I don't really see any difference.
What do you guys think in chat? Is my white so terribly printed?
Looks good to me. Maybe we can do some like bridging test, overhang test, this type of thing, to see if if white prints worse. But yeah, I know. So the thing that is said about white is it's very abrasive, is weak, and it doesn't print well. And that's what PrintBuster is going to test. We're going to test these 3 thing that we are saying about white. I saw a couple of questions already. Builders Mark. Other testing question: has Polymaker had any testing with common oil, grease, lubricant for a project using a printed bearing, or wanted to have lubricant added to bearing? Is there any information on that? Maybe one note before that. So this is a PrintBuster stream, right? We're really trying to differentiate what we're doing in Polymaker and PrintBuster. So we can communicate with Polymaker to see if they have done any testing, but that is a good idea for PrintBusters. I think we can do some more chemical tests, and I'm also interested in the weather resistant test. That's why I bought a weather resistant accelerated weather machine, because I'm so interested in this. Can discuss at another time. Do not interrupt this testing. Yeah, any suggestion on testing? Feel free to join our PrintBuster Discord, and we have. Do we have chemical resistant already? Let me check.
I don't think that's in there yet.
Oh, then that's a good suggestion. Oh yeah, chemical resistant. Yeah, it's already in there.
It is. Okay.
Yeah, so we have chemical resistance. So maybe that's some tests we can you can post there. Nick, my white ABS issue on my first Voron was layer adhesion. Oh yeah, that's a good point. We also need to test the Z-axis for the hook test. So that's another thing that we need to test. We only did the XY so far. But that's a good point. It could be that the layer adhesion is much weaker. Blah, blah, blah. How about if you have an additive like glitter too? Yeah, that's another thing we can test. I saw in oh, did we just lost medic? Can you guys still hear me? Hello. Okay, I hope you can hear me. So if you can still hear me, the glitter is a good idea. Okay, you can hear me. Okay, so we just lost medic. Yeah, like you know, for example, the point makeup and chroma have a lot of different effect and stuff. So maybe we can try how does this affect the mechanical properties. That's a good idea. Okay, you're back, medic.
Sorry about that. OBS just crashed on me.
Okay, so Curio Junkie was asking about the glitter. How does it affect? So I think it's a good idea to test all the different things out there, like silk, metallic, matte, etc., and see how each affect the mechanical properties. That could be some good test.
So that's my goal. Ultimately, I'd like to have every color in the world on this sheet. Unfortunately, I had to start somewhere.
Mm-hmm.
So I started with what I used the most. And one of my big questions was I love KVP ABS, probably my favorite ABS of all time. It's really expensive. So my big question was, is it worth the extra money over other brands that I use like Polymaker or eSun? And that data isn't in there. It's I was surprised to find out that there is not a very big difference. And it's actually a small enough difference that I can't really justify the extra cost unless I want that color specifically. The Stellar Blue is probably my all-time favorite color, but I don't use much of it because it is, I think it's $38 a kilogram plus shipping, and the shipping on it was astronomical. Not quite as bad as Prusa, but it was bad.
Really?
So I was looking at spending about $50 a kilogram, all included, which I just can't do for 1 kilogram of material.
Yeah, I'm hoping that all the Printbuster data that will be collected will really help people making more informed decision on their purchase, so that they understand more of the value of the product, and then they can make their own decision on whether price worth it or not. It was printed on a very sketchy enclosure on a horrible printer, so who knows what the cause was. I mean, it could be. I wouldn't. My hypothesis would be, and this is just a judgment, that it's possible that white is weaker in terms of layer adhesion. But yeah, now we need to test it, right? Is there a separate Discord? Yeah, absolutely, Chewy. And you're welcome to participate to the different discussion there. And thank you for sharing the link, Curio Junkie. And let me see if there's any other thing in the chat. It's funny you're all talking about the white because the bearing is printed in Polytera PLA white. It printing perfectly. Because the bearing is printed in Polytera PLA white. Which bearing? Sorry. Yeah, sorry, I missed that. Business mark. Prusa, you need to have a kidney buyer. Yeah, well, they are trying to solve this, right? They are working more and more closely with printed solid. Yeah, printed solid. So I'm hoping they have pretty good materials. So I'm hoping the US will have more accessibility to these materials, and also for Printbusters will be a little bit cheaper to do all the testing. So it would be great to have them here.
Yeah, my first experience with the Prusament PLA was when I bought the XL. It came with 1 kilogram, and it prints beautifully. It is a phenomenal material. I need to get some test hooks printed so I can get that tested. So what are we doing next? We have to, I say we, I have to print all of these same materials vertically so that we can test layer adhesion. I'm going to use the same test hook for that. I don't think that's a very good test for layer adhesion because of the way it puts stress on the test piece. So I will do a few, and we'll see how that goes. If I can get consistent results, I think I can call that a good enough test.
Mm-hmm.
Otherwise, it'll have to wait until I finish building the fancy actual tensile tester, and we'll do some dog bones with that once we get that set up.
Cool. Sounds good.
So vertical test pieces and HDT. One of my other questions was, if it's not good for printers, is it a temperature thing?
Mm-hmm.
So I was doing some testing with a toaster, and people weren't particularly thrilled with that toaster.
Okay.
So Edge 3D ordered a lab oven, and I've been staring at the listing myself for about a month now. That should be ordered sometime next week. I think that will be more consistent and might make more people happy. The other reason for that is all of these annealed samples. For those of you that know me, know I love my engineering materials, nylons in particular. But in testing the new PPS from Polymaker, we found annealing it takes very consistent temperatures. And the way I've been annealing, I have an old smoker that I have converted into my filament dryer and annealing spot. But the temperature varies a little bit because of how it vents out the top. I think that variance in temperature, plus or minus 5 to 10 degrees each way, I think is too much. And it's not annealing correctly. So once we get, I said we again, once I go and get myself a lab oven, I want to compare my toaster oven, which would be the budget option that anybody can go out and pick up for $20 at Walmart, versus the smoker, kind of a mid-range option that somebody might have sitting out back rusting away, which was my case, and the lab grade oven as the higher end option. I want to see how they compare to each other to say, all right, this really isn't good enough for annealing. We need something better. Or maybe the results will be identical and we can say, yeah, the $20 toaster is perfect. We'll see how that tests out.
Yeah, and ideally, what would be amazing would be there is a way, but the machine is super expensive, but maybe we can try to get the machine to define the crystallinity degree of the sample so that we can have, if you have the crystallinity degree at, I don't know, 5%, and then here's the result, and then 10% here the result, and then 15% here the result, right? Until full crystallinity at, I don't know, 30% or something. And then what we could do also is anneal it in different way and see how, like, what would be the annealing setting that would reach the highest crystallinity or something like this. Yeah, that's super cool. So if you guys want to build, most of what Medic is doing is very affordable, right? You can do that at home. And then Edge of 3D as well is building some testing device that you can build at home, and everything is shared on our Discord. I will also receive some device, but I'm a little bit lazier in that group. I just buy something that is done, but hopefully that will provide some other set of data that we could use also in Print Busters, right?
Yeah, so Nick has contacts with people that do fancy things. So I'm using Nick a little bit here. Nick is going to go buy the fancy stuff, and he's going to send me a bunch of pictures of what it looks like and how it operates. And I'm going to do my best to replicate that on a budget.
Oh, good idea.
And so my goal is to be able to make a version that works well enough, but is budget friendly so that anybody can do it at home and not need $1 million worth of test equipment in their garage.
Good idea. Good idea.
Sand. So yes, one of the things I need to test more is using sand for annealing. When you anneal these materials, they tend to deform quite a bit in some cases. And for complex geometries, that's an issue. So one of the solutions to that is to put sand in a bucket with the piece you're trying to anneal inside the middle of that sand bucket. The question is, how long does it take for the center of that bucket to reach temperature?
Oh, I thought the sand, for me, the sand was used for better annealing in a way that the sand will allow a much slower cooling so that it can crystallize much better. Does it really help with, well, I guess it depends. If it's slowly softening, then it provides a bit of support. But if it's yeah, I'm not too sure how the sand is actually helping with.
So the sand definitely helps with even heating and cooling of the part, which is great. But if you have a large bridge section and you go to anneal that, as you bring it closer to temperature, it's going to start to sag. By having a bucket filled with sand, there's now support here. So it won't sag like that.
Okay. So it help a little bit with like thin parts, bridge part, etc. Okay, makes sense. Cool. I think we are a little bit over the hour, and most likely all the print busters will be overtime anyway.
Yeah, I stopped testing at that last one, even though we got 3 more, because I realized we were over time already, and I didn't want to take everybody's entire Friday night.
So, yeah, anything else you want to say before we close the stream?
I don't think I have anything else tonight.
Okay.
But I'm always in the Discord if you guys have questions, and I'd love to continue the conversation there. But I'm sure my wife is getting hungry, and everybody else is too.
Awesome. Yeah. Thanks again for all the testing, Medic. You can find us on Twitter, Discord, YouTube, and Twitch. Printbuster 3D for all the different platforms. And yeah, so we are very active on the Discord. We will do more and more stream on Twitch and YouTube. And if any of you have some test result or want to do some tests on stream, please reach out to us. We will welcome everyone that want to do some tests. Printbusters is about learning more from a 3D printing science perspective, right? Same for the Twitter. We are retweeting some cool tests, so make sure to follow our Twitter. And then we anything from a test result to a text jigs or discussion around 3D printing will be shared also on our Twitter. Is YouTube working now? Yes, it is working now. We are live on YouTube. I don't know if there is anyone from YouTube here because I see only Twitch comment. But yes, we are also on YouTube. So you can go back to all the live, and I will re-upload Printbuster 1 and Printbuster 2, and I will re-upload them on YouTube so that you have access to all of them. Yeah, thanks again, Medic, for the testing tonight. Thanks again, everyone, for joining. And
thanks everybody for stopping in.
I see you guys in the next Printbusters. Thank you, guys.